Hi there, these are the 3.5 notes. This is going to be a pretty quick video, fingers crossed. What I want to do is start out with introducing these postulates and theorems that you guys are going to be seeing in this chapter. You don't have to write all of these down because you are going to have them on that postulates and theorems sheet already. Basically, this is like a lot of the postulates and theorems that we've been dealing with recently, where it's stuff that's kind of like, okay, we already knew that, but now we're making it into an official postulate or an official theorem. So for example, it's saying like, okay, if we have corresponding angles that are congruent, then we know that the lines are parallel. And that's actually the converse of the original corresponding angles postulate, which says that if you have two lines cut by a transversal and they're two parallel lines cut by the transversal, then you would have corresponding angles congruent. So it goes on like that. And then the thing that I really want to look at with you is how do we use this information? So they might give you a question like this. Given that angle 1 is congruent to angle 3, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. So if I have angle 1 congruent to angle 3, what does that tell me? Did I write that right? Let me double check. Okay, yes, it seems that I did write that correctly. Oh, I know what happened. Okay, sorry, I drew this a little bit wrong. Because that didn't look right at all. There we go. That's angle 3, that's angle 2. So now angle 3 and angle 1, that looks better. Drew my transversal wrong. So if we know that those are congruent, well, those are corresponding angles. And if they're corresponding angles and they're congruent, then that means that the lines that they're on are parallel. So yes, we can say that line A is parallel to line B, and that would be by the converse of corresponding angles. All right, that's my justification. All right, similarly, if we have the measure of angle 1 is 103 and the measure of angle 4 is 100, can we prove any of the lines parallel? Is that what it's? 1 and 4, yep. So, this is one of the ones where you have to kind of, you can literally erase if you want, like I just did. The other angles, we don't care about line B, honestly, right now. So you don't have the luxury of just being able to erase it like that and then pull it back up. But I can do that. So we're looking at angle 1 and angle 4. And those are along lines A and C, so that's what I need to be focusing on. They are alternate interior angles to each other. And what they're saying here is that they're not the same measure. So they're alternate interior, but not the same measure. So they're not congruent. So we can't say that they are parallel. Or we can say that they're not parallel. That is not parallel to C. Okay, I'm gonna give you a try problem. Pew pew, right there. So if you have, let's do this one. If I tell you that the measure of angle 4 is 105 and the measure of angle 5 is 70, is it possible to prove that any of the lines shown are parallel? So go ahead and give it a try. I'll come back with the answer. And the answer is that sadly it is not going to quite work, so no, we can't say that any of the lines are parallel. So we can't use that information to prove any parallel lines. Because if it had been 110, then you would have had some supplementary angles, and I think that might be a theorem up there, but it's not 110, it's 105, so it's not going to work. All right, there is another type of question. This is going to be example 2, and these are some of my favorite kinds of questions that we get in geometry, so I really hope that you guys don't hate them, but who's to say? When they give you a problem, oh, it's all labeled and stuff, and they give you some expressions. So this is 11x minus 25 degrees, and this is 7x plus 35 degrees over here. So helpful of them, isn't it? So this would be W, P, Q, X, Y, M, Z, and M. And for this one, what it says is find the measure of angle ZYN so that PQ is parallel to MN. So what we're saying here is that, like, if we want these lines to be parallel, then we know something about the relationship between this angle and this angle. We know that we want them to be congruent. So we would say that the measure of angle ZYN would have to be equal to the measure of angle WXP. So I can say that 7x plus 35 must be equal to 11x minus 25. I get 60 equals 4x divided by 4 divided by 4. I get 15 for x. But wait, that's not the end, because it says to find the measure of ZYN. So that's what x is, but that's not what my answer is needing to be. So this is something that catches so many people. Please, please, please try to be super careful with this. So ZYN, now we're saying that 7x plus 35 is going to be ZYN. So I just need to plug in my x to get what that measure would be. 7 times 15 would be, oh gosh, would it be 105? Oh wait, I know. I'll look at the answer. Okay, well, the final answer would be 140. So I guess we'll just go with that. Be 140. So that's cool. That's your final answer. Okay. Here is your try problem for that kind. And then that's going to be the end, actually, of this video. We'll do the word problem in class. Do, 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 do. Oh my goodness. So they are saying 7x minus 3 degrees here and 9x minus 21 degrees for this angle. And okay, so for this one, what I have drawn for you is angle BCD and angle BDE. And I would like you to find x so that BC is parallel to ED. This one is only asking you for x, so you don't need to find any angle measures, okay? All right, once you have that, you can check it. I believe your answer should be 9. All right, you guys. That's all. Have a good weekend. Bye-bye.